The universe has set two insurmountable walls for all civilizations. One is the speed of light, and the other is absolute zero. The speed of light is the ceiling you can never catch, and absolute zero is the floor you can never reach. The sun's surface is 5,500 degrees, capable of instantly vaporizing steel, but the destructive power of absolute zero is 10,000 times more terrifying than the sun. Because high heat only makes molecules move faster, while absolute zero literally presses the pause button on the entire universe. At negative 273.15 degrees Celsius, time almost loses meaning, chemical reactions completely stop, and even light becomes as viscous as syrup. But the most bizarre thing is that you can never truly reach this temperature. Quantum mechanics mandates that every particle must retain a tiny amount of energy, called zero-point energy, a bug hard-coded into the universe's foundational code. You can get infinitely close, but you will always miss the last step. What truly keeps scientists up at night is, what if a civilization actually breaks this iron rule and forcibly touches absolute zero? Some theories suggest that in that instant, the physical laws of the entire universe would completely collapse. Speaking of this, someone must be asking, how did ancient people know such a mysterious bottom line existed in the universe, even without thermometers? Over 200 years ago, a Frenchman named Gay-Lussac was conducting what seemed like a very boring experiment. He filled a glass tube with gas, then heated and cooled it, recording the volume change. With such a simple operation, he discovered a chilling rule. No matter what the gas, the volume would decrease by a fixed, small amount for every degree of temperature drop. He took this data and drew a graph, and all the data points lined up perfectly into a straight line. Even more terrifying, extending this line, it intersected the horizontal axis exactly at negative 273 degrees. What did that intersection point mean? It meant the gas volume became zero. It completely vanished. But how can matter vanish into thin air? So Lussac understood. That point was not where matter disappeared, but a red line drawn by the universe that nothing is allowed to cross. Later, scientists used more precise methods and finally locked the number at negative 273.15 degrees Celsius. This is the origin of absolute zero, a mathematically calculated cosmic forbidden zone. Where exactly is this temperature terrifying? Many people think cold just means freezing to death. People cannot survive negative 80 or 90 degrees in Antarctica. But the horror of absolute zero is completely different from your understanding of cold. The temperature we usually talk about is actually describing how agitated atoms are. When boiling water, water molecules frantically run around, so the temperature is high. When water freezes into ice, the molecules settle down, so the temperature is low. Absolute zero is the critical point where atoms stop moving completely. Imagine what would happen if a living person were instantly thrown into this environment. Your tens of trillions of cells, each with countless atoms, would all stop instantly. Not slowly freezing, but instantly halting. Your brain would not have time to form a single thought, your blood would not have time to clot, and your heart would not finish its last beat. Everything would be stuck in that instant, like a permanently frozen photograph. Moreover, your corpse would become the most perfect specimen in the universe because bacteria would also be frozen. Nothing could decompose you. You would remain in that pose until the end of time. But honestly, this is just the appetizer. What truly drives physicists crazy are the anti-physics magic tricks that matter performs when approaching absolute zero. First, the strange phenomenon called superconductivity. Early last century, a Dutch scientist was cooling metals and noticed a bizarre effect. When the temperature dropped low enough, the electrical resistance of certain metals suddenly went to zero. What does that mean? It means current flows through it with absolutely no resistance. If you run current through a superconducting loop and then unplug the power, the current will keep running, not for a day or two, but theoretically until the universe ends. In normal wires we use, current always heats up and loses energy. That is common sense, right? But superconductors completely tear up that common sense. Electrons run through them smoother than a bullet train, with zero energy waste. The second strange phenomenon is even weirder: superfluidity. Scientists cool helium until it becomes liquid at about -271 degrees Celsius. But this liquid helium is completely different from normal liquids. It has zero viscosity and flows like a ghost. If you pour it into a cup, it will climb the cup wall on its own, flow over the rim, and escape. No one is pushing it. There is no external force. It simply wants to run away. Even more outrageous, if you put it in a container that appears completely sealed, it can seep out through atomic-level crevices, as if the liquid itself has a kind of consciousness and knows how to find every exit invisible to the naked eye. The scientists who first saw this experiment probably wondered if they were seeing a ghost. But these are nothing. The next one is the real showstopper. In 1995, two American scientists created something that only existed in textbooks: Bose-Einstein condensate, BEC, the fifth state of matter: solid, liquid, gas, plasma, and then this. What is so bizarre about it? In this state, thousands of atoms lose their individuality and become one single entity, not just squeezed together, but truly merged. They begin vibrating in exactly the same way and moving in exactly the same way, as if thousands of people suddenly shared one single brain. NASA built a dedicated cold atom lab on the International Space Station to study this. Scientists there witnessed a phenomenon that makes your scalp crawl. A single atom appeared in two different locations simultaneously. You heard that right. The same atom, at the same moment, in two places. This is absolutely impossible in our world. You cannot be in the living room and the bedroom simultaneously. But in that extreme cold, the wild rules of the quantum world begin to invade reality, and the atom can truly split itself. How far have humans gone to touch this forbidden zone? In 2021, scientists at the University of Bremen, Germany, set a record. They cooled a cloud of atoms to just 38 trillionths of a degree above absolute zero. The number is written as 0.000000000038 Kelvin, 11 zeros after the decimal point. This temperature is so low that no thermometer can measure it. Scientists must calculate it by reverse engineering the atom's speed of movement. To achieve this, they dropped the device containing the atoms from a 120-meter high tower. During those few seconds of freefall, the atoms were freed from the constraints of gravity, and their speed dropped to almost zero. For those short 2 seconds, that tower in Germany became the coldest corner of the entire known universe. Speaking of the universe, can you guess if there is such a cold place in nature? There is. 5,000 light-years from Earth, there is a nebula called the Boomerang Nebula. It is a gas cloud ejected by a dying star, expanding at 500,000 kilometers per hour. This frantic expansion creates a dramatic cooling effect, similar to how the surface of a balloon cools when you quickly release the air inside. The temperature of the Boomerang Nebula is only -272 degrees Celsius, just over 1 degree away from absolute zero. How exaggerated is this? The Big Bang left behind residual heat called cosmic microwave background, CMB, radiation, which is about -270 degrees Celsius, essentially the average body temperature of the universe. The Boomerang Nebula is actually colder than the universe itself. It is the coldest natural object ever discovered by humans. Period. The existence of the Boomerang Nebula reveals a cruel truth. The universe is gradually heading toward extreme cold. There is a law in physics called entropy, which simply states that heat always flows from high temperature to low temperature until both sides are equally cold. Stars are burning, but they will eventually run out of fuel. Black holes are devouring, but they will eventually evaporate. When the last bit of heat dissipates from the universe, the entire cosmos will infinitely approach absolute zero. At that time, no reactions will occur, no energy will flow, and even time will lose meaning. Scientists call this heat death, or Big Chill, the ultimate death of the universe. In the heat death universe, there is no light, no heat, no sound, and no motion. All that remains is eternal, absolute, boundless silence. So, where is the horror of absolute zero? It is not merely cold. It is the end of existence itself. When atoms stop moving, chemical reactions cannot happen. When chemical reactions stop, life cannot exist. When everything is still, what meaning does time hold? Some people ask, if you freeze yourself close to absolute zero, can you achieve immortality? Theoretically, you would indeed stop aging because everything in your body has stopped. But the problem is that your thoughts, feelings, and consciousness all require atomic motion to be generated. When the atoms stop moving, you cease to exist. This is the most cruel paradox of absolute zero. It gives you eternity, but it robs you of the ability to perceive that eternity. You will exist forever, but you will never know you exist. The universe locks space with the speed of light, preventing any civilization from traveling far enough. It locks time with absolute zero, preventing any existence from lasting long enough. These two walls trap all intelligent life on their own tiny, isolated islands. Perhaps one day, a civilization will break one of these walls. When that happens, all our understanding of the universe will be completely rewritten. But until that day comes, absolute zero remains the ultimate curse hanging over the heads of all civilizations. It reminds us that the end of the universe is not a sea of fire, but a sea of deathly silence. And that deathly silence is slowly closing in on us with every second that passes.